The Doppler Effect. Oops, looks like Mr. Thompson's got a new toy that makes noise. Let's listen to the pitch of it. The Doppler rocket. Did you hear the pitch of the Doppler rocket change while he was swinging it around? If not, watch this clip over again and compare the pitch of the Doppler rocket when it's not moving to the Doppler rocket when he's swinging it around. So it seems like the pitch of a sound changes when the source of the sound moves. But you know what? You've heard this many, many times before. In fact, here's a common example where the pitch of a horn is going to change as the car drives by. Now, what do you think the horn sounded like if you were riding in the van? You wouldn't have heard the pitch of the horn change at all. It's only on the outside of the van as the van drives by that you are hearing the pitch change. So apparently the fact that the source of sound is moving makes the pitch change for somebody who is outside the van. So it's not a real change in pitch, it's just a perceived change in pitch that the hearer is hearing as the source of sound drives by. Let's watch and listen to this clip again. And this time we're going to compare the van that's going by at 35 miles an hour, and there's another clip with the van going 70 miles an hour, twice as fast, and there's two big differences between the van going 70 and the van going 35. So let's see if you can pick out what are the two differences. Well, what differences did you hear? Well, before we talk about them, let me first of all say that that change in pitch that you heard as the van was driving by is called the Doppler effect. When the van was approaching at 70 miles an hour, the pitch that you hear is higher than when the van is approaching the same way but only at 35 miles an hour. If you didn't hear this, go back and listen. In both cases, as the van goes by, we hear the pitch go from a higher pitch to a lower pitch, which we're going to try to explain in a moment. But the change in pitch, how far the pitch changes, the amount that the pitch changes, is bigger for the van that was traveling faster. So it starts out at a higher frequency and goes down to a lower frequency for the faster van. Before we go on, it's important to realize that the actual pitch of the horn never changes. If we were riding inside the van, we would hear the horn sound the same the whole time. We know that the way that the horn operates, moving the horn doesn't change the pitch of the horn. Inside the car, it sounds the same the whole time. But for some reason, when we are outside the van, as the van drives by, we hear the pitch of the horn change. So what we really want to do here is we want to try to answer two questions. Number one, why does the pitch of a moving sound source appear to change? And number two, we noticed as the van drove by, the pitch went from a higher pitch to a lower pitch as the van drives by. So we want to know, why does it go from high pitch to low pitch? To answer these questions, let's see the waves made by the van's horn when it isn't moving. Notice that the waves are the same in every direction. The frequency of the waves, which we hear as pitch, would be seen as the number of wavelengths that go by per second. So if the waves are really close together, we would say that's a high pitch. If they're really far apart, we would say that that's a low pitch. Now we're going to let the van move. The van is going to move towards the bottom of the screen. And notice that in the direction that the van is moving, the waves are closer together. And as the van moves away, the waves are farther apart. This is because the van is moving towards the waves that it has made in the direction of motion, and it is moving away from the waves that are behind it. So I notice that in front of the van, the wavelengths are closer together. The wavelengths are shorter. That's a higher frequency. And behind the van, the waves are farther apart. In front of the van, the horn makes a wave, and the van drives in behind that, so when it makes the next wave, they're closer together. Behind it, the van is driving away from the waves that it has just made, so the wavelengths are farther apart. So this is an area where the frequency would be higher than it normally is, and this is an area where the frequency would be lower than it normally is. So in front of the van, I can see that I will have a high frequency, and behind the van, I can see I will have a lower frequency. So if I think back to the sound that the van made when it went by, if I start right here, I can see that I will be in a higher frequency, and if I go back here, I can see that I will be in a lower frequency. So as the van drives by, it will make the familiar Doppler effect sound. So to summarize, what we've been talking about is called the Doppler effect. The Doppler effect is a perceived change in pitch caused by relative motion between the source of a sound and an observer. We've been concentrating on the source of the sound moving and the observer being stationary. But actually, we would also have the Doppler effect. We would also hear a change in pitch if the observer was moving and the source of sound was stationary. Whenever there is a relative motion between source of sound and observer, you hear a change in pitch, and the name of that is called the Doppler effect.